let me start by saying that ensure you go back, and this also holds for those who are joining the class this semester, meaning those who are doing APT 300S. You need to, in order to get a better gist of chapter 11, you need to go back to chapter 10. Chapter 10 is online already. That was the last chapter we did in semester 1, in the first semester. So please, the recordings, everything, the calculation, the note, everything is online. So make sure you go to your Blackboard. For those who doing APT 300S, it's already in your on Blackboard for you. And then for those registered for CTH, it's been there since last semester. So please ensure you go back to that. So if you remember from last semester, so we talked about, so please ensure you go there and refresh your memory. So if you remember, we talked about the fact that there are different steams, different steam types. Can anyone, let's see how many can still remember. Can you put in the chat panel, what are the different steam types you remember? There are different types of steam. We talked about steam as a working fluid in the last chapter. What are the different steams? Any takers that we looked at in the last chapter? Different steams. Let's see as how many people can still remember. What are the different types of steams? STEAMS, steams. Thank you. 2190. I'd really appreciate if you can change that to your name. You know, it's usually nice if when I can connect, since I'm not able to connect with you physically, I'll be able to just mention your name. So thank you, 219. Thank you, wet steam, dry steam, and superheated steam. Thank you for that. So yeah, so we mentioned that those are the different types of steam. And then from that, we also mentioned the fact that the different steams serve different purposes. Different steams serve different purposes. And based on that, and based on the ability of the steam to fulfill, for the steam, different steam types to fulfill its purpose, it's essential for us to measure the dryness. So those are some of the calculations we did in the last chapter, chapter 10 last semester. We looked at that using the steam table. So please go back and refresh your memory about that. That's that. Can someone also remind me, I mean, this is not the first time you'll be hearing calorimeter in this subject. What other type of calorimeter have we talked about before? Any takers? So today you are going to be looking at 3 types of calorimeters again. Any takers on the type of calorimeters we've looked at in time past? On the name of a calorimeter we've looked at in time past, in the previous class, in the previous classes? Any takers on that? Bomb calorimeter. Thanks, Bandile Letano. Thank you, Moshin Muhammad. I see. Thank you so much for that. Yes, so bomb calorimeter. So we've seen that from the previous class. So one of the things I want you to note from those is the fact that, so they serve different purposes. So they serve different purposes. So one of the things that I would expect you to do based out of curiosity, out of you learning more, is to go back and then see how does bomb calorimeter differ from the other 3 types of calorimeters we'll be looking at today. So are they similar? Obviously, you see, usually they have thermometer because in order to measure the temperature. And we also, from the other calorimeters, we talked about how bomb calorimeter, how it measures the quantity of heat. So I want you to look at those. I want you to go back and do the comparison. So if I were you, I'll draw a table. a table, the 3 different calorimeters, and then I'll put on the side how they work or the principle, and then I'm going to just tabulate that. So that is something I want you to go back and do after the class. So for the other ones we'll be looking at today, the emphasis is on measuring the dryness of the steam. You remember from what we mentioned earlier on, we said we have different types of steam. So it starts from the wet, goes through the dry, and then the superheated steam. So it shows you that the superheated steam must be very dry. And also, if you look at the table, there was a chart that we have in the previous class. So it must be very dry. And that is the purpose of the different calorimeters we're looking at. So the first calorimeter I'll be looking at today, which is the throttling calorimeter. When you hear the word throttle, for those of you that are familiar with cars, that love cars, you know that when you talk about throttle, for example, you talk about, when you press down on the accelerator, when you're adjusting with the clutch, there is a pumping of your petrol. There is a pumping of the petrol, and there is a movement of the petrol through a valve. So in throttling, that is what happens. Your steam comes in as wet steam from the steam pipe. So there is a boiler that is generating. So there is a boiler that is generating the steam. So there is a boiler generating the steam. And from the boiler, the steam goes into the bomb calorimeter. So this will be your throttling calorimeter rather. So it comes into your throttling calorimeter. We'll see the other types of calorimeter as we move on. And from your boiler, so the steam comes in through the pipe. So as the steam is going in, it comes from a place of higher pressure. So it comes from a place of higher pressure through a valve into a place of lower pressure. So the steam comes in through a valve. So when it goes through the valve, so it's going in high pressure and it goes out low pressure. So that is what you see here. You see a P1 and you see a P2. So your P1 is greater than P2. Take note of that. Another principle you want to take note of is this is a constant enthalpy process. If you remember where this subject started from, we looked at adiabatic system and isochronic. We looked at different types of isothermal. We looked at different processes. So take note, it's an adiabatic process, meaning your quantity of heat, the heat transfer is 0, and also no work is done. And if H1 is equal to, so this, you can play around with this based on also, so your PV relationships, we've done that in previously. So from your PV relationships, once H1 is equal to H2, so you can see that this will happen, and that will happen. So your Q equals to 0, your W equal to 0. All right. Any comment before I move on there? So please don't hesitate to raise your hand or type in. So please take note of those different characteristics: enthalpy, pressure, work done, the Q, and the fact that it's an adiabatic process. Another thing you want to take note of is the fact that since it's a throttling calorimeter, as I mentioned, it comes in as a throttling calorimeter. The steam is forced through a valve. So that is how the process works. Steam gets forced through a valve. So which is what we call, so that is what throttling is. So it goes through an orifice or a valve. That is throttling. So this is the definition of your throttling. Remember, I've said it starts from a place of high pressure and then it moves to a place of lower pressure. So those are the things of throttling: high pressure, low pressure. You have an orifice. And then as you do that, what you also having is that the steam becomes superheated. So that is what it is. So take note of this equation. We've looked at this equation from chapter 10, and then to be clearer, when I work out the equations, when I work out the calculations as well. But take note of that. So measurements are made of the pressure. We've said P1 will be higher than P2. So we've talked about that. And also there's a temperature when it's coming in, there's a temperature when it's going out. If you check, oftentimes this temperature, the temperature T2 is higher than T1. So just go back and check, cross-check that in terms of the relationship with the temperature, but it will be clearer when we look at the calculations. So I've talked about how throttling calorimeter works. I've talked about the fact in terms of the pressure change. I've talked about the temperature changes. I've talked about the fact that it is forced through an orifice or a valve. And I've also talked through the fact that it measures dryness or wetness of the steam. But the challenge and then the essence is that you want your steam to come in. So the steam is coming in as wet steam. It should go out as superheated steam. But it's got a challenge in the fact that sometimes the steam is too wet. So when the steam is too wet, so what that means is that when the steam is too wet, the throttling calorimeter, the steam you get will not become superheated. So the throttling will not work. So take note of that drawback or that challenge. So take note of that drawback or that challenge, which takes us to the next type of, so we'll look at this for tomorrow. So we'll look at that. I'm going to solve that and send to you. But so I'm going to send that and send to you. So take note, you take note of the pressure, temperature, and other quantities given. So this takes us to the next type of calorimeter. We've talked about the principle of throttling calorimeter. Now we've talked about how it works. So I want to quickly talk about the principle of separating calorimeter and how it works. So one, we've said it works, the purpose, as the name is to separate. What does it separate? It takes wetness out of the steam. Remember that the steam is generated by boiling water at a particular temperature and pressure, but some of the water can still be contained in the steam, and we don't want that. So which is why we talk about dryness. So separating calorimeter is used to remove this wetness. So what is the principle? How does it work? Principle for the previous calorimeter, we said force through an orifice. Principle of separating calorimeter, the wet steam comes in. As it comes in, there is a sudden change in direction. Sudden change in direction. This is usually this occurs usually by the help of centrifugal force. So there is a change in direction, and as the direction of, there's a sudden change in the direction of the, so the steam hits a mesh. So there is a mesh here. Let me get the pen. So the steam is coming in from here. There's a sudden change in direction. You could see this arrow, sudden change in direction. It hits this mesh. And as this is happening, the wet part comes down, and we have a dry steam going out. So that is the separating calorimeter for you. So we've talked about the challenge, we've talked about the principle, how it works. Then another thing you want to ask yourself is, does it also have a drawback or a challenge, as we saw for throttling calorimeter? Yes, it does. What is the challenge of this? The measurement of the dryness is not accurate. The measurement of the dryness is not accurate, which is going to take us to the last calorimeter for the day. So I've mentioned this already. So this is a major drawback here. An approximation, it's an approximation. It is, so because of this, you're saying it is not accurate. So please take note of this. You will see this in the calculation. So the dry steam, remember, wet steam comes in, dry steam goes out. So we use these calculations. M is the mass of water separated and collected in the calorimeter. So if you remember, I showed you this. So your M is there. So we have our M here. So take note of that. And M, bigger M, so the dry steam that is going out. So please take note of that. Collected, then the dryness fraction. So this would be the dryness fraction. So the original thing, so the dry, the wet, the dry with the water. So this will constitute the wet steam, M plus M. So big M plus M, small m, this will constitute your wet steam. This constitutes your dry steam. So you remember, so that's why we call this wet mixture, meaning it's got some water in it and then it's got, so take note of that. So based on the drawback or the challenge associated with this, so you see I'm going to solve this calculation, send to you as well. But like I said, it's not going to be any harm if you look at this example ahead of time. You do some Google, you go online as well, or you use your body system. All right. So the final, so based on the drawback, we've seen throttling calorimeter drawback. We move to separating calorimeter. You said separating calorimeter as a drawback. So now you're saying there's another type of calorimeter called combined calorimeter. So from the name, it has two components, and it's a component of the two things, the two calorimeters we've talked about. So it starts with the throttling calorimeter, and then we have the separating calorimeter. So what that tells you is that by the time the steam comes out from the last end, it should be dry. So of all the three calorimeters, it should be obvious to you that it should be obvious now that the one that measures dryness most accurately will be the combined calorimeter. So the sample comes in from the steam engine, from the boiler, it goes through. So the two calorimeters are arranged in series. So it first goes through the separating calorimeter. So it means that the steam that will be coming, from here. So sorry about that. The steam that will be coming from this. So the steam that will be coming from here will be partially dry. The steam coming through here is wet, partially dry. What we have here should be dry and superheated. Are we clear on that? So that is a combined, combined calorimeter. So that's why we have X1 and X2. So there is a dryness at this point, there is a dryness at that point. And then similar to what we've done before, we have this. We'll look at this example, but I'm going to stop at this point and then take take questions.